The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to another ClearEdge 3D webinar. Today we are going to be talking about scanning and modeling complex pharmaceutical and medical research facilities. That's a mouthful. And you'll see from the projects, these are pretty complex spaces as well. We've got some great guests with us here today, and we'll get to introductions in just a second. But we'll go ahead and get started looking at our introduction, our agenda, and some housekeeping stuff. So again, we'll introduce the panel and next, and then we have the individual case studies. So we'll start out with the advanced 3D case study, move on to BIM Connections, and we'll have some time at the end for Q&A. So definitely, if you have questions along the way, jot them down and pop them in the GoToWebinar questions area, and we'll coordinate those and queue them up at the end. All of the participants are muted during the presentation, so if you try and talk to us, we definitely won't hear you. So make sure you're asking questions through the chat. And again, we'll kind of coordinate those for the end, and I'll queue up the different panelists for it. This webinar is being recorded, so while we certainly want you to stick on for the whole thing and participate, if you've got to run halfway through or something like that, in about a week or two, we will have a recorded session sent out to everybody that registered. So if you're on here, and you've obviously registered, so you will get that link. Yeah, so with that, we'll move on to the fun part. So we'll start here with Lewis. So Lewis is joining us from the UK. So first off, thank you for staying a little bit late today. As you can see here, Lewis has a ton of experience in the plant and process world, 16 years total, 10 years on a really large refinery in England. So 10 years on one job, that's quite a long time, Lewis. You with me?
Yep, sorry, I forgot to unmute it, so I've already started with the clumsy bit. Yes, 10 years. Worked at the refinery for about 10 years, and I've actually had quite a few family members that worked at the same refinery. My dad was a instrumentation engineer by trade, and my granddad was a part stress analysis for the refinery as well. So as a family, we were down there for about 25, 30 years.
All right, well, that's definitely some tenure. Fantastic. And as you can see on the bottom, he is nicknamed Bambi. So if you have any questions specifically for Lewis, you can also address them to Bambi, and he'll be happy to take those at the end.
Thank you very much.
Thanks, Lewis. And Herb, let's get you pulled up here. So Herb is the owner of actually two companies, BIM Connection and Innovative Plumbing and Mechanical LLC, a design build firm. So that's pretty interesting. Background, of course, in mechanical engineering, and apparently loves to play basketball.
Yes, that is correct. Not much, you can see, not much of a three-point shooter, but I love the game. It's very collaborative and team-oriented. It
is indeed. All righty, and let's pop down and talk to Ivan for a minute or two here. So Ivan was actually the toughest person to get information up on the screen, because he sent me a list of titles, and it's a list. There's like 7 titles. So he also sent this lovely image. So he is apparently the Swiss Army knife at BIM Connection. Maybe you should put that on your business card, Ivan.
Yeah, I guess Master of None is my best title.
All righty, and YouTube cat videos.
Yeah, why not?
Fair enough. Fair enough. You know, if ever come to Texas, particularly the Dallas area, there's actually a restaurant in downtown Dallas that has YouTube cat videos playing, projected on one of the walls the entire time it's open.
That's just perfect for me, huh?
Yep, absolutely. Let me know if you're there. I'll point you in the right direction. All righty. And with that, let's turn it over to Lewis here for a few minutes to talk about this particular project.
Thank you very much. Can you all hear me? Just check that I have definitely unmuted this. So our company, Advanced 3D Laser Solutions, we actually specialize in the oil and gas industry. By that, we don't touch anything like the BIM industry or anything like that. And we constantly trying to looking forward into looking for new technology to help the oil and gas industry. And we've been going for about 4 years now, and we've got quite a lot of work in UK, Rotterdam, and we've actually got some work coming up in America in the next couple of months. So we're doing quite well. So the next slide, please. So this particular case study is actually about the pharmaceutical industry. We actually did a job for a pharmaceutical firm in the UK. We normally just specialise within oil and gas, but this particular client came up. It was quite an interesting intro to the client as well. We're working around the corner. We do a lot of work for a company called CLH, and they have a lot of underground tanks, which is really interesting. And we go inside these tanks and scan and work out where the load points are. But when we was driving past one of these sites, we'd noticed this pharmaceutical firm, and we got our commercial, or the commercial director, to give them a call, and they kind of gave us the usual spiel that they've already had the whole site scanned and everything was modelled, and they're all happy and they're not fussed about seeing us. So we said to them, look, okay, you might have the whole site done, but can we drop off a brochure? And lo and behold, we actually got a phone call 2 weeks later after dropping the brochure off, and they loved everything they'd seen and wanted us to come down. And since then, we've done about 3 of their sites, which is absolutely amazing. So one of the areas that I'm going to speak about today is about the lanolin plant they had on site. Lanolin, from what I understand, is kind of one of these base products that's used in almost everything. So anything from women's makeups to shampoos and shower gels and whatnot. What they wanted, though, was a complete set of accurate P&RDs or PFDs, depending on exactly how you explain the difference. The issues this particular client had is that going through the traditional route, they were using local firms and university graduates that are doing that are working from to try and survey the area, but each time they were physically failing, and they were struggling to keep up to date with new updates and new additions to the plant. They contacted us and just said, look, this is the worst area we've got. We've got an upcoming HAZOP, and we physically need these P&RDs, and what can you do? Like I said, the particular issues with this particular area was because it was one of the oldest units, it was subject to so many different changes that pipework was literally snaking around the whole site, and because of, especially with pharmaceutical stuff, less likely with oil and gas, but with pharmaceuticals, because they've got such small bore pipework, they just run it wherever they want, and they just get a couple of pipe fitters in, decide, and just let them basically run wherever they want. They can physically run this pipework, so you just end up with this absolute snake pit of pipework, and it's almost impossible to trace. And because of how in-depth all this pipework was, there was a lot of redundant pipework, and including heavy lagging, because a lot of the stuff that they were passing through pipework had electrical or steam tracing in it to try and keep the product warm. Next slide, please. So we said to the client that we could go in. We'll go into this particular plant. We'll scan it, and we did. We used the Focus, which is what you see on the slide here. It's a particular scanner that we use quite a lot. For instance, this is actually a screen grab from last week, where we were actually scanning a oil storage depot. There's actually 4 scanners. The gentleman on the right, Joshua, he's actually hiding one of the scanners. But there was 3 of us using 4 of these scanners. And we scanned, I think it was 120,000 square meter area in 5 days it was, and there was about 70 tanks, 10 road loading bays, about it was about 10 pump slabs, 4 of these LPG spheres, 2 jetties. It was a big area, but we was able to accomplish it. Sorry, I'm kind of veering off topic here. So for this particular job for the pharmaceutical firm, we went in with 2 of the Faro focuses. We had about 24 spheres because the particular area we were surveying was really congested. We just knew that we'd have to put quite a tight knit of spheres down to make sure we could get in as many scans as possible. We used just a lightweight tripod rather than a great big bulky one, just so that we could keep moving it around really quickly and whatnot. And the ground was really sturdy, so we wasn't worried about that. It was not like it's going to be wet mud because it was actually indoors. And we was able to accomplish something like 60 scans, so 30 scans per scanner a day. Because it was quite a tight area, we was able to use just very short scans. I think the settings we had it set up on were about 6 minutes. So every 6 minutes, was able to quickly pick up that scanner, move it into a different position, and just start that scan again. And we kept the color photos on. And I'm hoping the next slide. So I've got a couple of these little quick tips that I find particularly useful, stuff that I've learned from over the years. I've lost that. There it is. It's lots of small scans. This is not something I'd agree with when you're doing oil and gas sites, because they're very well spaced out, but certainly for these kind of pharmaceutical firms, because there's just such a tight knit of pipework everywhere, you just need to keep moving that scanner into just small positions, like just a meter on or a meter to the left or the right. Just keep moving it and do as many scans as you can, because this small pipework, which can go down to 1/2 inch plastic or something, it can just easily be hidden behind a smaller pipe, a bigger pipe, for instance. So I definitely recommend, if you're scanning a site like that, just keep moving that scanner into lots of different positions and get as many scans as you can. Don't worry about racking up those scan settings, so you're using longer scans. Just use the small ones if you can, that is.
And just out of curiosity, were you using a lift to get different heights on the scanner or anything like that, or just sticking it on a tripod?
Site was all right. It was it had loads of different floors, so we was able to just keep going up through the different floors. This particular site again had a central reservation going for it, which allowed us to put a lot of spheres on the base. So this is a great picture. I apologise for the I went through this presentation a couple of times and it never moved when I was doing it, but never mind. But as you can see on the picture on the right, this is the particular building, and you're going to notice that it's obviously in 4 different colours. This screen grab's taken from Pharma, which is where we use to register all the scans together. And the reason that they're in different colours is because we've actually clustered them up. So we locked them into separate clusters or folders, as you are, so that we're able to scan a particular area. Say we get 60 scans roughly per floor, register them all together, lock them into a cluster, and then move on to the next floor. And then once you've done all 4 floors, for instance, with this particular job, all we need to do then is just register 4 different clusters together. It makes the whole job so much easier to register. Okay, so look, there we go. So the registering, we tried to do a lot of our pre-processing. So we tried to do so as soon as we finish the scanning, we take the SD cards out of our the scanners, and if we're staying locally, because obviously we're in Essex, and I think this particular job was up north somewhere, so we stayed in a Premier Inn. Each night we download the SD cards into Pharma, do all the pre-processing, leave the laptop just running overnight, just number crunching through those 60 scans, because there's a lot that goes through it. There's a lot of filters it goes through. Needs to apply the color, the point cloud settings, quite a lot. So we try to run this every night, and it also allows us to work out if we've missed out any scans. Now the beauty with the new Scene software, the Scene 7, it allows you to actually register a lot of the scans into separate projects. So for instance, Joshua, my right hand man as it were, he does a lot of the registering. So I might work on one floor, he'll work on the second floor, and I'll work on the third and the fourth. And once we've got all those floors together, working on different machines, obviously, we actually bring those 4 projects together into a single project and then register them all together. And by doing that, like for instance, we've just done a particular project which, like I said, was 120,000 square meters, and was able to register it all together in 2 days. And traditionally, that would take something like 5 or 6 days. So there's a huge time saving. Okay, so this particular video, if it plays, it might be a bit jittery. It's just a look at the point cloud data. This is just a video fly through that we did for the client, just to get a bit of an idea of exactly how much we scanned. And you can see through the 4 different floors how much point cloud data and how much we was able to capture. And there's very little blank areas, as it were. You can even see some of the spheres in there. I've obviously cropped out the walls and the ceiling just so you can see exactly what's going inside. Yeah, there's a lot of point cloud data in there.
You can definitely see how dense all that pipework is, lots of different levels.
Absolutely, and this really benefited with the P&RDs, because obviously we can trace that pipe where it is going through like one floor and trace it using the point cloud data to see exactly where it would go through another floor. So there's no lost in translation that you're looking at the wrong pipe, because you can just literally follow it using that point cloud data exactly where it goes through and which way it goes and which vessel or pump it goes into next. So once we've got all this point cloud done, we didn't go straight on to start creating the P&RDs, because this is what this particular job was about. We actually went on to create the model, and this was the beauty of this particular project. We was actually able to convince the client that not only can we produce the P&RDs quickly and accurately, but we can also, for the same price that you would normally pay for a 2-3 man team to go through here, and they predicted it would take something like a year just to produce the P&RDs for this particular area, that we could do the whole lot within, I think it was something like a 12-week turnaround, and we produced a 3D model for them, an accurate 3D model that they could use later on for project work or for piping isometrics for NDT work, and the list goes on. What you're looking at here, though, is the point cloud data within Edgewise, the ClearEdge Edgewise plant software. And the orange 3D vectors that you're looking at is actually all the pipe work that Edgewise found automatically. So at this point, we have done nothing. All we've done is literally put the point cloud data into it, allowed it to run overnight, and come in the next morning, and this is the sort of image we'll be looking at. So it picked up on something like 80% of the pipe work, I believe it was. We've still got to go through a couple of steps of adding elbows and T's, but again, a lot of that is automated. I don't think I missed anything out there. One other quick tip when it comes to this, comes into modeling projects out like this, is to try and break that project down into logical areas. Now, again, I bring up the oil and gas job that we've just done. Every 3 or 4 tanks, the tanks were broken up into a new separate bund, and these bunds were given particular names like bund A, bund B, bund C. And we actually, we have broken each bund down into its own separate project. So say there's 50 scans per bund, we'll actually put bund A's point cloud data into Edgewise, let it run that overnight, and then the next day we'll run bund B into it, bund C into it, and again it just shrinks that down and makes it a lot easier to manage. Not to say that Edgewise can't manage the whole terminal, but just us physically, it allows us to understand exactly what we're looking at, and just allows you to focus on just one thing at a time rather than the whole job. And by doing that, you do actually save a lot of time.
Yeah, this is actually something we hear from a lot of our users, both with Edgewise and Verity. It's just, doing the entire plant in one pass is appealing, and it's, I think, what a lot of people do the first time they run the software. But then you have this massive thing with tens of thousands of pipes that have been extracted that you're looking through, and it's a little overwhelming. So I love this tip. This
Absolutely. Absolutely, and this is not just for Edgewise either. If you're working with an Autodesk product, then obviously at some point you've got to run all this point cloud data through recaps so you can access it within your AutoCAD package. And I'd again recommend just splitting that down into the similar kind of size projects. Right, so moving on, this particular image again is just looking at another section of the particular plant. Now you're going to notice that we haven't just got orange pipes this time. The reason for that is the Edgewise software will actually color code the auto extracted pipes dependent on its size. Now, one of the things, and I'm sure I'm stepping on some feet here, but one of the things that you need to bear in mind with Edgewise software is that it's not a pipework extraction software, it's a cylinder extraction software. And the reason I say that is that you probably noticed that roughly in the middle of this image, you can see it's picked up on all the handrails, because let's face it, there's nothing different between a pipe and a handrail. They're all cylinders. So that is one of the things that Edgewise does pick up on. But there's a lot of added functionality within Edgewise that allows you to go through and say, look, I'm not interested in anything that's less than an inch. So you can quickly just select everything that's less than 25 mil, for instance, and just delete it out. And by doing that, you pretty much remove all the handrails straight away. But that's just something to bear in mind, that this Edgewise software picks up on cylinders, picks up on cylinders, and obviously pipework cylinders. So just bear in mind anything else. For instance, even the great big green pipe that goes across the bottom, that is actually a I think it was some sort of exchanger, I believe, heat exchange. But again, because it's cylindrical, it's picked up on it. And again, the next image, you'll notice this particular vessel, again, it's just a cylinder, but Edgewise has picked up on it. And you'll actually notice as well in the background that it's actually picked up on the what you call them, oil storage barrels as well. So it does pick up on just cylinders, but that's not a flaw, because like I said, you've got plenty of tools in there to be able to just delete out everything that you don't need. Okay, so the next image. So when we actually started using another piece of software that I'm not going to name, but it was a manual piece of pipe extraction software. And I brought this up in other webinars with Edgewise. Now, we started using this piece of software, and it was a bolt-on within the AutoCAD package. And unfortunately, at the time, this was something like 4 years ago, Edgewise wasn't available for Autodesk products, or not with Plant 3D. So it could extract the pipes into AutoCAD, but it wouldn't have any of that, lost my words, what's the word I'm looking for? Didn't have any of that functionality in it. So it didn't understand that if you exported a 8-inch pipe from Edgewise, that pipe that came into Plant 3D was still 8-inch. If it went into AutoCAD, it just saw it as a 200 mil pipe, 200 mil cylinder, and that was it. So at the time, we wasn't able to have that use Edgewise, but we stayed in contact with Otto, which was the salesman we was using. Thankfully, after about a year, we got contacted by Otto, and he spoke about that they were really interested in getting Edgewise to be able to work with Plant 3D, and if we could work with them, and we was really chuffed and we was really excited to be able to use this Edgewise package, because obviously
for our American listeners, chuffed is excited. Little translation there.
Oh, I see. Sorry. Apologies. So yeah, so we was really excited that we could use this package, because a lot of the videos that I'd seen with Otto, and we'd spoke about all the different ideas, and ClearEdge as a company got on with it. And when it started using this new plugin that allowed us to take the Edgewise pipework into Plant 3D, it was just so fast and accurate that it just, like for instance, we did a oil storage depot, which is quite a small depot. It only had about 9 tanks in it and 5 road loading bays and whatnot. And originally, it took us 3 months to model it out using this manual pipe extraction software. And this manual pipe extraction software had a lot of bugs in it, and but I'm not going to go into that too much. But once we'd used Edgewise, we did it on a similar size depot, and we was able to complete it in with something like 4 weeks, I believe it was. So it was 3 times the speed, and it was a lot less stressful, And because it wasn't a direct plugin within AutoCAD, it meant that we could run all the Edgewise registering on one machine. So whilst one guy is finding all the pipe within Edgewise and doing the last little cleanup, the other guy could start setting up the AutoCAD Plant 3D package and getting your project ready, and all the point cloud data ran through recap and whatnot. So it was a lot quicker. Now this particular image is not the finished article, but it's halfway through the project. So what we've done here, we've rendered the point cloud through Edgewise, we've exported it, brought it into Autodesk Plant 3D, and added all the extra bits, so including pipe supports and flanges and valves. You can do this within Edgewise, but it's not something that we've particularly tested, because there was so many different specs going on within this project. So they had plastic lines, stainless steel, carbon steel. They even had this unusual fiberglass one because they worked with a couple of nasty acids. They even had this carbon steel 150-pound flange spec. So it was a lot easier for us to just dump the Edgewise pipe straight into the project and then start converting it into the particular specs that we required for it. Okay, so the next image. So I think I've gone through quite a few. I've jumped the gun on a few bits. So like I said, once we've imported the Edgewise pipe work, we use the Plant 3D catalog to add all the valves and the fittings. It's just a lot quicker and easier. And obviously we add the major pieces of equipment, so like your pumps and your tanks and exchangers and whatnot. Once we've done that, we'll actually go through and start line numbering everything, and this allows us to directly work with the PNIDs, and I'll come on to that. I believe I've got a slide coming on talking about the PNIDs, but there is kind of a reason for that. Again, it's just another snapshot looking at the Plant 3D model. Now, Autodesk PNID, originally we did a lot of our PNIDs using just AutoCAD Line, so there was no functionality within it. It was just what we class as a dumb 2D file. It was just lines and blocks and text, and that was it. Now, a lot of our clients were starting to get back to us and say, look, oh, thanks for doing the PNID, it's all good, it's all accurate and whatnot, but we want you to build a report showing every single piece of equipment, or every single flange number, or every single valve number, and what line that was on. And it became this huge job for us to go through, and it was a manual function to go through every single PNID, write down exactly what flange or valve and what line it was on. And it was taking absolutely forever, almost as long as it did to actually originally draw the PNIDs. So we started looking into intelligent PNIDs. Now, intelligent PNIDs, for people that don't fully understand that kind of terminology, everything that you draw within the Autodesk PNID suite, or there is a couple of other smart PNID suites out there, it's built on a database. So when you draw in a line, for instance, as soon as you draw that line in and you've given it a line number, that line number is attached to that database. And so as soon as you add a valve against it, again, that is linked to the database, and that database understands that that particular line number's got 3 valves onto it, and those 3 valves have adopted that spec that has been attached to the particular line number. And that is only one of the benefits. Like, the other benefit is that it's a lot faster to CAD with. Like certain benefits, like for instance, when you're drawing vertical lines. So if we look at the previous slide, sorry. Thank you. If you notice, some of the vertical lines for the process lines, they are broken. So if you pass through a horizontal line, they're automatically broken to make sure there's no misconception that that particular line is joined on. Sometimes you see little jump overs, but that traditionally, using the dumb basic AutoCAD, thank you very much, AutoCAD 2D function, you'd have to manually break that line. And I know it's not a particular job, but once you start doing 200-300 of them, it becomes quite a slow task. Also, when you add in valves on, it automatically breaks the line so that you haven't got that line passing through it. And for a company like us that specialise in just doing almost a day-to-day job, we've got 3 people here that all they do is create P&LDs. They create P&LDs from either doing site surveys or from a similar project like this pharmaceutical one, where they're using the 3D model as a survey method. So we've created this really accurate 3D model, and they're using that 3D model to work out where all the lines are going. The AutoCAD 2D P&LD solution also has got this validation check. So everything that you model within your 3D model will also validate against the 2D P&LD. So, for instance, if you've got an 8-inch modelled line and you've got 2 valves on it, and you've got this 2D P&LD that's linked to the 3D model with the 2 valves on it, it'll actually check to say, yes, you're right, it has got 2 gate valves in there, and they're meant to be 6-inch, and they're meant to be calm steel 150 pound. So it's a great checking method to say, yes, that 3D model is exactly what's on the P&LD, and vice versa. Now, once we'd completed this and done all the P&LDs for them, and they were really happy, and the HAZOP went absolutely fantastic, we actually got contacted back, and they said, we're actually adding this new piece of kit, and we're hoping that you could possibly model in this new piece of kit for us and work out where it's going to go and exactly where you're going to be running this pipework. Because at the moment, all this pipework's going through all these different floors, and this particular heat exchanger that you're looking at was going to be somewhere on the 1st floor, and this next bit of kit that's going to tie into was on like the 3rd floor. So we said to them, yeah, that's great, yeah, we've got the 3D model, we can do that for you, and we'll work out where we're going to tie into your chiller lines and stuff like that, and how we're going to actually get this vented gas that's coming off 2 vessels to actually make its way down into this exchanger. So they're really excited. And to be honest, we were, because this was one of the first projects that we contacted the supplier and said, look, our client are about to buy like this exchanger and this compressor and whatnot from yourselves, and I wondered if you had a 3D model of it. And they said, yes, absolutely. We've created these accurate inventor 3D models of our kit, and they're accessible to you. Like, give us your email address and we'll send them over to you. And it was amazing. So we've got these 2 pieces of kit through via email. We dragged and dropped them straight onto our Plant 3D project, and it came through 1-to-1, and it was absolutely amazing. So this particular video animation, you can see the particular heat exchanger at the top there, and the blue line is where it's taking the vent gas off the 2 vessels, brings it into the top of the exchanger. The red line is showing the cooling water return, green is showing the cooling water supply, and you can see the compressor down the bottom left now. And this was just brought in, and it's very similar to a BIM project that we're able to bring in all these different outside models and bring them straight into our project, pipe straight from it, and it worked seamlessly. And we was able to do this in like days. And he said to me, this particular client, he said that it's just absolutely amazing. And originally it would have taken us a couple of weeks and a couple of guys to come down the site and constantly try and work out the best way of doing it, exactly where they're going to pipe into, how big this new piece of kit's going to be. I was even able to work out the steel, so we knew exactly where this new piece of kit was going to go and where it should sit exactly over that steelwork. So it was really exciting. And just apart from working out exactly where this kit was going to go and how it was going to pipe it up, was able to produce all these accurate isometrics and the bill of materials. So he was actually able to show his boss and say, look, this is how much this new project is going to cost us. And with that particular video fly through that you saw a minute ago, he was able to show his boss and say, look, this is what we're going to get built. And his boss was excited. It's like, wow, I don't have to look at these boring 2D drawings. I've got this beautiful 3D model that I can spin around, and I know that the blue line is the process, the green is the cooling water supply, and the red is the return of it. I know exactly what's going on. I don't have to be an engineer, because again, a lot of these bosses these days are accountants, and so they're very good with money, but they're not particularly good with engineering projects. But he was able to really visualize exactly what's going on. So he was really excited, and we're really looking forward to working on more projects with this particular site. But yeah, so I think I've covered everything. Tell me if I haven't, Chris.
I think you've got it all, and we will of course have some questions at the end. So
I look forward to it. Look forward to it. Yeah.
we've got
Ask
a
me.
number of them. Hey, thank you very much. We've got a number of questions queued up for you, but we will swap on over to the BIM Connections case study and get Herb and Ivan unmuted and pulled up.
Thanks very much. Speak to you later.
All right. We have you, Herb, Ivan?
Yeah, we sure are. Can you hear us okay?
Absolutely. Take it away.
Okay, great. Well, appreciate the queue up. Again, we're BIM Connection. We're a Oregon-based company in the Northwest, and we work on medical, higher ed, commercial, just various types of buildings. This comes as a dovetail to Lewis's nice presentation here, where we wanted to share with you one of our recent projects involving a university, major university in Oregon, University of Oregon in Eugene, on a science building project. As you can see, just as a primer, the goal of this project was to renovate all the existing MEP systems and build back the MEP systems because there was a funding available to create 16 new research labs involving new scientists being hired onto the university. About a 30,000 square foot project. And one of the unique things about this project is that we wanted to show the high density of MEP equipment, kind of similar to some of the projects that Lewis has been working on as well. As a firm, we support the engineering community as well as many MEP contractors, usually in pre-construction land. Other than that, other parameters of the project, our Scan to BIM team used Faro scanners, as you can see there. This whole project took roughly 100 scans on 4 levels in the basement. Other aspects of the project in terms of survey control, that was provided by the contractor, and the scan data was used to validate that control. We found an issue that was later verified and resolved as well. Some of the scanning challenges, we found that with the hallways that are long and linear, they tend to belly, and so the remedy was to use adequate survey control and registration methods to QC that type of effect. Next slide, please. Okay, other basics in terms of registration software, Ferrocene, with the combination of cloud-based and target-based methods. Ivan, who will be presenting the visuals on this project later, was our BIM modeler, and obviously we had the support of our field team partner, as well as the software they used in Ferrocene. We have 2 teams. One works in manufacturing projects. The second team of discussion today is our BIM team. That team uses primarily Autodesk-based software. We receive the scan data, and then we're usually in a recap in a Revit environment as we work on design assist, design build type of projects where our utilization of Revit helps us to integrate upstream with the design team as well as downstream with plugins such as SysQ for the shop drawings as we provide our full service process. From an Edgewise perspective, we've partnered with Edgewise probably on the order of 2 years now. Been very pleased. We feel that in terms of benchmarking, we can reap about a 30% savings in modeling time. And so for us, that's very significant. Therefore, in our opinion, the ROI is very quick. Next slide, please. Other than that, unique aspects of this project, the science project, again, the controls are provided by the contractor. We do feel that from a best practices standpoint, to have scanning completed from a surveyor's perspective is very important. It's very value added, and obviously basics such as good communication with the clients as the requirements, deliverables, as we've all experienced, tend to change throughout the project. One technique we can comment on is when dealing with trouble spots, we tend to register in a way where we can make small clusters of scans in L shapes, and it helps them lock the scan data together.
That's a really interesting one. I haven't heard that before. I kind of like that.
Yeah, with that backdrop, I'm going to invite Ivan and also Tom, one of our team scan team members, to comment on the remainder. And I'll pass the baton over to Ivan so Ivan can go through some visuals inclusive of the video after this as well.
So I guess we'll just scroll through a couple of slides and then we'll jump to a quick project walkthrough video. And these slides are kind of basic scan to BIM workflow, which is, I guess, amazingly straightforward and user-friendly. So we receive a point cloud from our scan partners. And in this case, we're looking at the mechanical room of Pacific Hall. Next slide, please.
And it does take a second for it to refresh on your end.
Yeah,
so.
sure, absolutely. So then we just model the equipment in Revit. Next slide. And we run point cloud to edgewise and recognize all the pipes, ducts, walls, and structural elements. Next slide. So, and now we can remove the point cloud and we got a perfect 3D as-built. Can you start our video, Kelly?
Yeah, let me go ahead and hop to that.
Yep. So yeah, and this is the HVAC, kind of the same process. So yeah, this is a University of Oregon Pacific Hall. So first, we're going to be flying through an attic corridor. So all of these docs were generated in edgewise and then translated into a Revit RVT format. And I modeled the blowers in Revit. And this is a typical floor. So we processed the entire building, but this is just one of the floors. So it's not really congested, but still lots of pipes, lots of ducts. And the last one is the basement, the mechanical room, probably the most interesting area. It's very packed, pipes, ducts, and conduits. So this is where edgewise was extremely helpful. And I guess, like Herb mentioned, edgewise helped us to cut down the hours by at least 30% on this particular project. And the final product was extremely accurate. I think there's no way I could model it manually with the same level of precision. And also keep in mind that this was our first project using edgewise. So I think nowadays it would save us like 50–70% of hours. So, and I guess what I like about edgewise is the simplicity of a workflow, because I usually set it up and just run it overnight. And then on the next day, I get a perfect base for my Revit model. And as you guys all know, capturing existing conditions and creating as-built is an essential part of every remodeling project. And it's usually a tedious process that nobody likes. And this sweet combination of point cloud and edgewise makes it very simple, quick, and actually pretty exciting. So thanks, ClearEdge, for amazing software.
I'm happy to provide. And actually, I in my former life had a scan to BIM team as part of my group, and this particular image here just brings back nightmares of a couple projects that we worked on. And yeah, it's one of the challenges with these is you can imagine walking into that space with a notebook and a tape measure, and
I don't really want to imagine that.
Yeah, it's just being able to apply technology to solve the problem a little bit more easily is a phenomenal thing to have at your disposal, certainly. So and actually I have a question. I know a lot of this was focused on the kind of mechanical room and piping. Were you guys using Edgewise for the exterior of the building, or and did you scan the exterior of the building?
Not really.
Okay, so no scans out there. This is all focused on the inside because it was
Right, correct. Yep.
Gotcha.
Yeah.
It's MEP remodeled, so.
Just double checking because I saw it in the model. All right. Well, let me pop down to the end here. And we'll just we'll go straight to Q&A. We've actually got about 13 minutes for Q&A, which is fantastic. So if everybody would unmute themselves, and we'll start going through some of the questions that we've got from the audience here. All right. So, okay, all right. So the first question that I've got is coming from Ocean Van. So, hi Ocean, how you doing? Ocean's with DPR, so recognize the name. Did you have an issue with cleanup and having to set up containment in space? So this, I think, is to Lewis.
Was the as in like to stop people from walking around, or clean up of the actual particular point cloud, or?
I think it's reading like containment or cleanup and containment. So I'm thinking it's a site safety scenario, since you guys were working in a
Unfortunately, it was a running site, so we have to contend with operators obviously walking up and down, and we have to give them full access. But when we turn up on site, and we turn up on any site, we sit down with the operators and just tell them what's going on, that the laser scanner is not anything dangerous, it's only a pulse laser. And if you need us out of the area, just let us know. We'll shut the scanner down. We'll work somewhere else, and we'll leave some spheres behind so we can work on something else. So yes, there's never been a particular issue, and it happens every so often that we need to be moved out for a couple of hours. But like I say, we just leave a couple of spheres behind, and we make sure we just tie ourselves back in afterwards. So no, there's never been any particular issues.
All righty. And we have from Pierre here, how do you trace a pipe through the cloud? Is there an automation method, or is it using section slices? So that's kind of an Edgewise question. So Pierre, basically the way Edgewise works is we utilize computer vision algorithms to actually detect the pipe within the cloud automatically. So you don't have a person having to slice sections or kind of follow a pipe through the cloud by flying through. We'll detect those in the data by looking for cylinders. We usually detect somewhere between 70, 80, even 90% of the pipes, depending on the data set. And then there may be a couple that you've got to go in and fill in. If they're really small, they didn't have good coverage, things like that. We've got some tools to automatically connect systems, and you can always go through and refine them further. Let's see. So also from Ocean, did you have, Lewis, did you have issues with noises from reflection on stainless steel materials?
Yeah, unfortunately, that is one of the pains. There's not much you can really do with it, and I've tested it. I've actually had access to a small bit of stainless steel pipe and tried just scanning it at different settings. Unfortunately, you're always going to get noise on it. When it came to the actual using noisy point cloud data within Edgewise, it's not been much of an issue. It really hasn't. Sometimes you get like a small bit of reflection. You almost get this pipe on a pipe, and they're about an inch apart, and you get a bit of an issue with that. But again, that's nothing to do with Edgewise. It's more to do with laser scanning. Unfortunately, it's just one of the disadvantages of laser scanning. Because it is a laser, it's going to reflect off stuff. But there wasn't a huge amount of issue. Thankfully, this particular site, thankfully I can't name the client, but it was quite a dirty site. So a lot of the stainless steel was had a lot of crud over it, so a lot of it wasn't getting reflected. If it was something like the food industry, where a lot of the pipework is super clean and super polished, I'm not quite sure how you'd get around that. I've read certain case studies where they've actually gone in with a with a floury water sort of substance where they've actually sprayed the pipework down just to give it a bit of, stop that reflection a little bit. But yeah, it's not something I'd be particularly happy with doing. But again, for this particular job, it wasn't an issue for us.
All righty. And then I think this is, this one's going to be a question for Ivan and Herb. I'll let you guys take this. When exported from Edgewise to Revit, do the pipes come in as families, or what category? How does it go from modeling after processing with Edgewise?
So yeah, it comes as a family. So it's perfectly natural for Revit.
Yeah, and it's all the different systems go in as intelligent data. There's not a 3D export process into something like CAD that then's brought in. It's actually, there's a plug-in for Revit. We recreate everything natively through the API.
Right.
All right. Okay. And so just here's another question, probably for both panelists, just to share your experience. This says from Casey, just to be sure, 75%, does that get converted to graphics objects, and only 25% is required for rework? So I think he's asking about the metric that you were both sharing about how much of the pipe work it had extracted automatically. So
we pipe up slightly differently. Yes, okay, it only picks up on about 75 to 80% depending on the project, but anything after, as long as it's found a part of a pipe for that particular run, once we bring it into Plant 3D, we just carry on that run within Plant 3D, and we're particularly happy with it. But you've got plenty of tools within Edgewise to actually manually pick out the missing pipe work, for instance, so it's not an issue. I hope that kind of answers the question.
Yeah, and Ivan, any thoughts on how y'all handle the remainder that doesn't get automatically extracted?
So yeah, I guess if I understand correctly, Edgewise extract 100% of pipes, and it just creates like small little spools, and all I do is just connect the spools together. So it's not exactly 75% and 25%, but it's more like 100% and a little bit of manual work.
Yeah, and you know, this is the amount that it can automatically extract is really dependent upon the noise and the data, the quality of the scan data, the material in the field, how, you know, scan coverage. There's a lot of factors that go into that, certainly. So it's certainly something we're working at. So for both panelists, or both groups of panelists again, from Ben Stevenson, for these large, complex laser scanning jobs, what is the best way to put together a proposal or bid to the owner? How do you break it down? How do you give options, etc.?
I suppose it depends on what the particular client wants. And sometimes the client doesn't even know what he wants. It depends on, obviously, with our country and with what we do, we try to do a lot on legislation. So we know what sort of legislation that these companies are coming up to, like with aging plant and NDT inspections. So we go in and we give them the whole package of exactly what we can do. And the fact that by laser scanning a particular site, you might not want the PNRDs today, or you might not want the 3D model today, but you've got that access to it. So like in a month's time, if this particular client comes back and he wants some more modeling done, he can. He's got being able to record the whole site in one quick swoop, and we've got all that data there ready for anything. So if he wants his piping isometrics or his API 570, it's there. If he wants a 3D model for clash detection, we bring a new piece of kit in, it's there. So it's trying to show the customer that by going in by laser scanning, it's just going to be a far greater method than any other survey method, because it's not about today's demand or what that client requires today, but it's what he needs in the future. And you've got all that data there, so it doesn't matter if you've scanned something in America and you're a UK-based firm. We don't have to go back out to America to scan it because we've got all this data back in our office. I hope that kind of makes sense.
Yeah, no, absolutely. Ivan or Herb, you guys have any thoughts to share on that?
Yeah, this is Herb. I agree with what Lewis is saying. Maybe to supplement or augment what he's mentioned in terms of proposal, going back to the basics, we feel that a job site walkthrough obviously is very important because there's always a good discussion in terms of validating what the actual requirements are. And beyond that, in terms of kind of the mechanics of a bid, hopefully this adds some value to the discussion, is that usually on a scan to BIM type of proposal, we usually provide a range of hours, on a T&M basis for the modeling. And we find that sometimes we do that because the LOD, the requirement of LOD changes as we go through the discovery process with what the design team requires as well as what the contracting team requires. And then on the scan side, we usually, in recent times, we've been proposing such that after the walkthrough, we kind of figure it's, once we mobilize, we want to get as much data as possible on a given day. So we might give a range of, say, on a given project that we quoted recently, anywhere between 3 to 5 days, depending on what happens when you start popping open ceiling panels, on the days of the scan. And then we go from there. Tom, do you want to add anything to that?
Hello, this is Thomas Walker. I'm a survey technician with HHPR. Yeah, I would say just knowing the client's needs is one of the bigger things. The site tour is definitely a good thing, and that's where you can discuss, what do you need, what are you trying to get out of this? And having that face-to-face conversation on site is really valuable.
All righty. Well, we've got time for one last question here. We've got a couple of questions from James asking just about kind of edgewise functionality. So he heard that Lewis, that you had added elbows and T's. So he asked, do the T's, flanges and valves export import into Revit yet? Also, does the export keep the user-defined radius on the elbows? James, in the current version, the answer to that is no. I'm very excited to tell you and everybody else on the line that in 2 to 3 weeks, we'll be releasing another new version of Edgewise that elbows, T's, reducers, and all of that will come into Revit. We do not have valves and flanges yet, but all the critical connectors will come in, and yes, it will respect the elbow radius. Happy that we're able to knock that one off the user request list. And structure does include C channels, angle iron, basically all the different AISC steel shapes. All right, and there's probably about 45 or 50 different questions in here. We, of course, do not have time to get to them all. What we'll do on our end is try and follow up with people as best we can if there are particular answers that weren't somewhere in the presentation. A couple of these looks like some people popped in late, maybe missed it. Again, we will be sending out a link to the recorded session in 1 to 2 weeks. So look for that for all the registrations. All the people that registered will get one. And if anyone, if you know of anybody that you think should see this, kind of shoot them the information if they go in and register. Now, obviously, they'll be too late to attend live, but they will also get the link to the recorded webinar. So, any other housekeeping stuff, Chris? I'll let you pop in for a second here if I missed anything. If not, all right. Well, then I'd say one last thank you to our wonderful panelists. Yeah, it was great speaking to you all today. Any closing comments from y'all?
No, not at all. Thank you very much for your time.
Yeah, thank you for hosting.
Thanks, Kelly.
Our pleasure. Okay. Well, with that, we'll conclude the webinar and look to follow up with everybody offline. Thank you. Bye.
Cheers.